Hi, welcome to the next episode of VCF Breakroom Chats. I'm Taka Uenishi, Product Marketing Engineer at Broadcom, and I lead product marketing for VCF Automation, which is a core component of VCF that powers the private cloud self-service experience. Today, we're going to talk about platform engineering and why it's becoming the operating model for modern AI-driven enterprises. And the focus is on what platform engineering actually is, why it matters, and how it changes life for platform engineers and developers. And so to unpack this, I'm joined by my partner in crime, Jad Elzain, Principal Technologist for Modern Applications with the VCF division. Jad, thanks for being here with us again today.
Hey, Taka, thanks for having me and excited to discuss platform engineering.
Awesome. All right, so let's start with an overview for our audience. The term
Mhm.
platform engineering, it's everywhere now, but it's still a little fuzzy for many people. How do you define platform engineering in practical terms?
Well, um, okay, practical terms. So, platform engineering is the discipline of designing and building the tool chains, the workflows, the self-service capabilities that ultimately the developers consume on a day-to-day basis. And it's packaged up as what's called an IDP or an internal development platform or an integrated development platform. And instead of every team, handcrafting infrastructure and release workflows, the platform team builds these golden paths. They are the reliable, secure, pre-approved, and governed ways to deploy applications, databases, services, and so on. And it's so developers can really focus on the code side versus maintaining underlying infrastructure.
Gotcha, gotcha. And you just mentioned, golden paths. Why are golden paths such a big deal for platform engineers and developers?
Well, the golden paths are really what's also called paved roads, right? They cut the cognitive load for developers by eliminating the complexity of the infrastructure and allowing them to focus on their apps instead, right? So the devs get an unobstructed path from idea to production that already bakes in the nuances of networking and security and observability and compliance and so on. And for platform engineers, golden paths turn a mess of unique one-off requests that are constantly raining in into standardized blueprints backed by a unified declarative API, and it's much easier to scale, automate, and measure when it all gets aligned properly.
Yeah, yeah, makes sense. Now, I read the latest, state of platform engineering report, and it shows that platform engineering is shifting from what it was a niche practice to more of this operating model for the modern enterprise, especially, with AI coming in. So, what is driving that shift?
Yeah, I mean, well, we're seeing this as well, obviously. And organizations have realized that just doing DevOps wasn't going to cut it, right? Everyone became responsible for everything. And while it had promise up front, I mean, there was a lot more to be desired, right? It created burnout and inconsistencies. There was added risk in a lot of situations. And so platform engineering brings structure by creating a dedicated team, the platform engineering team, that owns the platform and delivers it as a product, right? And at the same time, you've got AI and cloud native architectures, which multiply complexity. And so enterprises need, a standardized, secure platform to deliver these next gen workloads safely and repeatedly, and of course at reduced risk, which is always key.
Yeah, yeah. And that's a major shift. So, if you're a platform engineer, or maybe you're an aspiring platform engineer, what outcomes should you expect when your platform strategy is actually starting to work?
So, I mean, I think the outcomes are plenty, but for starters, you'll see faster lead time from code commit to production, possibly or likely lower change failure rates, better mean time to restore because the platform, remember, it's the idea here is to have it all declarative, observable, and automated end to end, right? So you also see higher developer satisfaction, which is always a good thing. Those teams are no longer fighting infrastructure, and we know that still happens. They're consuming a consistent catalog of established services through APIs or self-service portals, and doing it without all the noise.
Gotcha, gotcha. And let's get a little bit more concrete. So, how does platform engineering show up for Kubernetes and modern applications and in the real world?
I mean, Kubernetes is obviously a big driver here. And for Kubernetes, platform engineering means you don't just hand out generic clusters, right? Or waste time trying to perfectly scope the requirements based on an application that may or may not be fully scopable, right? Instead, you're exposing blueprints and namespaces and data services and virtual private clouds or VPCs, as well as like well-defined, and doing that all as well-defined products in your platform catalog, right? And behind the scenes, where the magic happens, I mean, everything is built on a composable API-first architecture, and it's managed through your typical declarative or well-adopted declarative GitOps practices, and environments are reproducible and easy to roll forward or back.
Got it. Got it. What about AI and those data centric workloads? How is platform engineering relevant there?
Well, I mean, AI is the ultimate modern app, right? So we have to treat it as such. And very rarely do we talk AI without Kubernetes and vice versa. So, AI workloads, we got to think of what they need, right? Consistent access to GPUs and their models and the data services. Of course, there's the secure networking, and its storage requirements and sometimes specific compute requirements. And this is often required across environments, right? And platform engineering gives AI teams a standard way to request those capabilities without the custom one-ops. So again, it's the standard repeatable practices. And so the platform exposes, for example, an AI workstation, something that's loaded with all the tools that an AI developer would need. And it's available as a catalog item. Maybe call it private AI services to align with what VMware has to offer there. And it's provided as a private cloud service, right? It becomes much easier to scale AI experimentation, while also meeting security, compliance, cost controls, access controls, and so on.
Oh, yeah, yeah, awesome. So some of our viewers, may be platform engineers, but maybe some of them don't think of themselves as traditional VMware people. So when does it make sense for them to pay attention to solutions like VMware Cloud Foundation or VCF?
For the non VMware people, if you're building an internal developer platform on top of a private cloud, VCF takes a ton of the burden off of you and your team. From the get-go, VCF treats VMs, containers, and Kubernetes as first-class citizens on a single or a unified declarative API-driven platform, right? Um, you gain the ability to provision everything from entire workload domains, which is the underlying compute infrastructure, to the networks and storage, to into the app space of namespaces and the Kubernetes clusters, all the related services in the extended ecosystem. And we're using common tools or blueprints. And this is quite attractive, especially when we blur the lines between VM and cloud native applications, which is a critical requirement for enterprise platforms today.
Got it, got it. But some platform engineers often ask, why not just standardize on something like OpenShift? How is platform engineering with VCF different?
I mean, why not? But the problem is, I mean, typically like a Kubernetes centric platform that was like built and came out of Kubernetes is continues to be very Kubernetes centric, right? I mean, they're great for provisioning clusters and runtime and for the runtime, but they stop at the boundary of the broader infrastructure. You still have to stitch together like the underlying thing, like networking and storage. You still have to consider lifecycle management outside of that domain, right? And then you got to get behind trying to run your critical virtual machines on that same exact platform. It's a tough sell, but with VCF platform engineers, they get an integrated stack. You got your compute, your storage, networking, your Kubernetes and container runtimes, your automation, your governance, and again, all exposed through this declarative API, very GitOps friendly workflows and integrations. And you can deliver these golden paths from your underlying infrastructure all the way up to the application services. It's not just for Kubernetes cluster provisioning. Everybody could run Kubernetes, right?
Hmm.
how it how it's tied into the broader ecosystem and gives you the end-to-end capabilities. That's what's critical.
Makes sense. Yeah. And you recently wrote it on a blog on it, but can you connect also, how this connect this to the five key principles that we've been talking about here and there around modern apps, around composability, GitOps, observability, zero trust, and platform engineering. How do they actually relate or show up in VCF?
Sure, yeah. So first off, I highly recommend your listeners read that blog post. But So VCF implements a composable API first platform. You're going to hear me say that over and over again.
Hmm.
And everything comes from, uh, we do this for everything from that core infrastructure to your Kubernetes clusters and the data services and so on, all of which can be requested through self-service blueprints and APIs. Again, it's just the things we were repeating. But VCF supports declarative GitOps style operations, observable and closed loop automation. It's got a built-in zero trust security model, something that's been proven for more than a decade. And platform engineers can embed those principles directly into their IDPs, and that's really the goal here. It's the quick start, right? And that's where VCF is positioned.
Hmm. Hmm. All right, cool. And so for someone that's early in their platform engineering journey, what are the first, one or two or three, moves that you'd recommend?
So I think that the thing that resonated most is taking a service and treating it as a product. So first, define your platform as a product and then determine what that product is going to be, right? What is it? Who are your internal customers? What are the golden paths? What are the enterprise needs that need to be part of those golden paths, right? What are the SLAs that you're going to commit to? And presumably these are all aligned with the enterprise or the line of business or both. And that product mindset is really foundational for getting started and throughout, right? Second, you're going to pick a golden path that you're going to get behind. Maybe a standardized or a standard Kubernetes app and data back service, right? What does a golden path look like to deliver those basic services? These are fundamentals, right? Implement them with the declarative definitions and Git, include observability and policy as code from day one, right? Get some of these quick wins and then plan for scale. So start small, prove the platform, and also start quick, and then grow from there.
Yeah, definitely the crawl, walk, run. Yeah.
Yeah.
And how can VCF help those teams, move from experiments to an actual repeatable platform?
As we've highlighted, VCF gives you the building blocks. Right now, I'm not going to ever try to convince you that this is the only solution you'll ever need. While we can possibly get there, sure, every platform can strive to getting there. But most importantly, you have to look at these solutions like VCF as the core building block. Determine what your unique needs are versus what the platform provides. But from a VCF perspective, as that core building block, you've got automation, you've got your requisite runtimes, your storage and networking, your AI services, your data services. You've got this policy wrapper, and it's all to codify those golden paths as reusable blueprints and publish them into the self-service catalog, which is provided by VCFA. And because the same platform again can this is your same proven virtual machine platform, your virtual machine runtime. It can support VMs, Kubernetes, AI services alike. You could evolve from a small pilot to an enterprise scale IDP without constantly replatforming, right? This is just an extension of what's likely in the enterprise today. And that's really VCF's magic sauce, I think.
Got it. Got it. Yeah. This has really been a great overview. But before, we wrap up, what's one key takeaway that you want every platform engineer or an aspiring platform engineer to kind of leave with?
One key takeaway. Okay, well, for starters, don't position platform engineering or don't think of it as a way to create more gates or controls because you'll fail, right? We don't want that. It's really about giving developers safer, faster ways to ship software by treating the platform itself as a product. right? And obviously by aligning with the enterprise needs. Now, if you pair that mindset with the composable API first, GitOps driven platform like VCF provides, um, this gives you the key or the opportunity to support Kubernetes, AI, and modern apps with the consistency and control that is demanded by the enterprise, right? So, lastly, if you should look at the platform engineering as the operating model for modern apps and AI, right?
Hmm.
And the outcomes really do matter. What did you gain? Speed, reliability, happy developers. These are all objectives we can get behind. And honestly, VCF was built for this task.
Gotcha. Well, thanks, Jad, for helping us understand what
Yeah.
platform engineering is.
Yeah, thanks, Taka. It was a great and very timely discussion, and I'm always happy to share my insights, as you know.
Gotcha, gotcha. All right. Well, hope you all like this episode. We look forward to continuing the conversation and helping you turn your platform engineering strategy, into a real developer-led platform. This is your host, Tako Inishi, signing off. Have an awesome week and see you until next time. Bye.